In this video, I'd like to fit some data in R using ggplot, and the data is going to be the distance and the period of the planets. So I'm going to reproduce Kepler's law, and I want to fit the equation, get a model, display the equation, and I've done this before, but at this time I wanted to use ggplot. Okay. Now I learned a lot from a lot of people, but I learned a lot from Statistics Globe. So I just wanted to give a shout out to him. Okay. So if you haven't run ggplot, then you'll have to install it. You can install it sort of over here in the packages, or you can run code. So I ran code, but I only ran it the first time and then comment that code out and then bring in the library. Okay, so bringing in the ggplot2 library. After we bring it in, we refer to it as ggplot, but the package at this stage is ggplot2. I'm going to use a read.csv and this website address, and that is going to turn the CSV into a data frame. And so let's show that much. So I have now brought in, I have the names of the planets, the periods of the planets, and the distances of the planets to the sun in some unit. Okay. And this, when we do read.csv, we have a data frame. So next we want to plot it. I have given a name to the plot. And I want to chain a lot of things together. And so I want to sort of give a name to it and then just keep adding to that name. But then that, strictly speaking, is in memory. And if I want to see it, then I have to run that entity that I made. I need to then sort of execute it. So we will see this structure again as I keep adding to kepplot and then showing kepplot. And I have a tendency to forget kepplot. It sort of helps me organize, but I also tend to sometimes forget the second step that this organization step makes necessary. There I am running it. So here I have my data plotted. So on my X, I have the distance. On my Y, I have the periods. So I'm plotting using the data Kepler. This AES stands for aesthetics. And that's where you specify that the X-axis is going to be distance and the Y-axis is going to be period. And then down here in the gm_point, that is where we are saying that it is going to be an XY scatter plot. Then I'm going to use X and Y, their values, to give me a place on a sort of a Cartesian coordinate system. And then the kep plot is just sort of what brings it down here into my plot region and shows it. And the size 4 is why I have these monster big dots. Okay. Now I want to it gave me some labeling. It said distance, it said period, but I wanted to add a title and also have some unit in the distance. I hope these units are right. So I did that with labels, and I said the title was Kepler's law, the x-axis, which already says distance by default, but I added the unit, and the y, it already said period, but I wanted to add the unit, and then redraw my graph. So now we have the title and the units in the X and Y axis labels. Okay, so that was labs. And some people I will see will chain and chain and chain. And I think I like this approach where you develop it more slowly and can comment things out, say I didn't want that, but not sort of disrupt your chain. So now I am giving it a little bit of color. So that is under theme. And I'm going to change the panel, which is right now gray. And I'm going to change the plot, which right now is white. And I'm using these RGB colors. So this color is all Fs would be white, so it's going to be a light color. I'm taking out, I have less red, so I have more green and blue, so it's going to be a greenish blue. And this down here is close to all 0, so it's almost black, but it's got, again, more blue and green, no red, but some blue. So it's going to be a very dark blue-green. And then I did the same thing for the plot background, just not quite as light a green, not quite as dark a green. I don't have that good of a style, but there's that very sort of aqua green blue. Okay. Then I wanted to, Kepler's law is a power law. There's a power law relationship between the period and distance and Kepler's third law. And first I tried to work completely within ggplot 2. And so I could specify that I wanted a sort of a nonlinear model, and then give my formula for the nonlinear model, and then give a starting point for my A and B. Actually, I gave the starting point of 1 and 1. And it would have, if I had forgotten this line, it would have chosen 1 and 1. So I'm not really doing anything except preventing it from yelling at me. And then this is like a standard error, so I don't want it spread out. So this worked. I've commented it out because it gave me a nice line through the plot. I'm sure it was a power law. That's what the data fits to. But I could not manage to extract the coefficient and power from this. And probably if I dug hard enough, I could find it somehow. Then it's in there. I mean, it must be in there since it's a decent looking curve, but I didn't know how to get it out of the ggplot. So I gave up on this approach and went to my old-fashioned. I went out to a linear model. A power law can be turned into a line if I take the log of the y's and the log of the x's. So that's what I did here. I took a linear model with the log of y as a function of the log of x, and then I summarized it just to sort of see it. But here's me extracting the coefficient. There's one of the coefficients, which is the intercept of the linear model. And then if I take the exponential of that, that's the coefficient of my power law. And if I take effectively the slope in my linear model, which has, the name of it is the name of the x, so it's log of Kepler $distance. And so that's effectively the slope, and the slope in this game is the power. So I have this is not going to change my graph, but I'm just establishing the model. And so now I have the model, Kepler fit is my model, and I've extracted explicitly from it the coefficient and the power. Okay, now I want to use that function in my graph to add it to my graph. So I'm defining the function here. So I'm defining using the coefficient and x raised to the power, I'm defining the function. Again, nothing on the graph just yet. but now I'm adding using stat underscore function, and I'm going to use the fun equals function equals my fit underscore function. That's this generic thing. This is my function that I want, and I chose its color to be orange. I chose its linear width or something, the line width to be 2, so it'll be sort of a thick line, and I made its alpha equal to 0.5, so it has some transparency, so it'll be thick. It won't overwrite all my dots. And so there is my orangey yellowy line with some transparency. It fits the data well. Kepler's law is pretty good. Okay, now I want, and this is why I was unhappy with the stat smooth, is because I now want to show on my plot the equation. I don't think there's any sense in getting a model unless you can then know the coefficients of the model and work with it. So here I am creating some text using pasting together, concatenating together some text. Y equals, I'm rounding the coefficient to 2 places, x raised to, I chose 3 digits for the power, so I can run that. And now I have y equals 1.73, x to the 1.5. It's not showing me 3 places because it's so close. It's so good to like 1.5 that even when you rounded it to 3 decimal places, it still effectively became 1.5. I'd probably have to show it to like 4 or 5 decimal places for it to move away from 1.5. Okay. So now I have the equation, and I'd like to put the equation on the graph. So I'm using here annotate for that. And so I can annotate with, things other than text, but I'm saying I'm going to use a text annotation. Where am I going to put it? I'm going to put it at an x of 10. So here's 0, 20, 40, 60 going across the bottom. I'm going to go to about 10, this first, well, not the first, I guess the second thin gray line. And then the y is going to be 500. So that's between 400 and 600, of course, is 500. So it's going to be about here. And the label is going to be my fit equation that I created above. And I'm going to make it the size of 6. So I'm going to put it in pretty big font. And so I run that. And there's my displayed equation, where the middle of the equation is about 10 and 500. So this is sort of, these values are sort of like the middle of the equation. And that's all I wanted to show you. So I wanted to, start using ggplot and not just the bare plotting abilities of R itself. But I wanted to sort of build up slowly. So make the, here we're making the plot. Geom point said that it was an XY scatter. Then we used text to, oh, I don't think I ever ran that. I'm sorry. Let me run the whole, I didn't run this geo text part. I jumped right down to the axis labels. So if I run that, it is going to give labels to my points. But I made the label an if else, instead of just saying label equals planet to display the name of the planets, the planets that are closest to the sun, Mercury, Venus, Earth, Mars, are sort of so close together that it'll just be this big overlap of text. So I just wrote this as an if else, and if the distance was bigger than 5, starting off with Jupiter, then then I'm going to show the planet. Otherwise, I'm going to show nothing. And I can sort of say how far horizontally or vertically I want to be from the point for my text. I didn't work too hard because poor Pluto's cut off, but some people will say it's not a planet anyway. So I'm glad I sort of reviewed because I forgot that one thing. So this geom text was labels. Labs was my title, my X and Y axis. Theme was my colors. Here I broke out of ggplot and did my model and extracted what I wanted from my model. I made a function corresponding to my model, and then I finally used stat function to plot my fit function. And then I used paste to create a text for my displayed equation, and then I used annotate to finally display the equation. So that's what I wanted to show you, a number of features of ggplot in order to get a power law fit to some data. Thanks for your attention.